everyone, welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on LeetCode. Before starting, if you guys haven't subscribed to my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3542. Minimum operations to convert all elements to 0. So let's read the problem statement. You are given an array nums of size n consisting of non-negative integers. Your task is to apply some possibly zero operations on the array so that all elements become 0, right? In one operation, you can select a sub-array I to j, right? And I and j both are inclusive, right? If you see these square brackets, right? And we have to set all the occurrences of the minimum non-negative integer in that sub-array to 0, right? So in the end we have to make zeros only, right? So this is what we need in the end, right? And if I'm picking any sub-array, right, here let's say we have 1 2 3 4 5 6 7, something like this, right? So I have to take this as one boundary, right? I have to consider these zeros as nothing but boundaries, right? Because if I consider these zeros in my sub array, then 0 will be the smaller element, right? Right? So I want to skip this 0 as well, right? While considering the sub arrays, right? So I can use this one sub array, I can use this one sub array, right? Because if you see in this sub array 5 is minimum, in this sub array 3 is minimum, in this sub array 1 is minimum, right? I can't take this complete as a whole one sub array, right, until here or complete, right? Because in that case 0 will be my smaller element, right? And if 0 is the smaller element, then then that simply means I am making 0 to 0 only, right? We have to run the minimum number of operations, so definitely I don't want to consider this 0. So I can say that if my sub array is like this, and let's suppose if I'm making all ones to 0, right? So I'm going to get something like this, right? Then next time I can't consider this as my whole sub array, right? So in that case 0 is going to act as a boundary, right? Then I have to consider this as 1 and this as 1, right? Okay, so again, then if in this subarray I take 0, so I'm going to make it in this subarray, I'm going to take this 2 only as one subarray, and I'm going to make it. So this is what actually we need to do, right? So we have to return the minimum number of operations required to make all elements in the array 0 finally, right? This is what we need, right? Clear? Now if you see example number 1, right? So we have something like this. First element is itself is 0, right? 0. Then we have 2. Okay, so this is already 0, right? And this is 2. So if I just consider this subarray, right, 0 index 1 index, so if I just consider this 1 1 subarray, right, only this 2, and if I make it 0, so then I will get something like this, both elements 0, right? Where the minimum non-negative integer is 2, setting all occurrences of 2 to 0 result in this. Thus the minimum number of operation required is 1. That's it. Clear? Now see this example number 2. We have 3, right, starting from here 3, then we have 1, then we have 2, okay, and then we have 1, right? This is what we have, right? So if you see here in this example, this is one layer, right? This is one layer, okay. This is other layer in which we have 2 as the max height of one slope in the mountains. Let's say these are nothing but the mountains, okay. Mountains are like this only, right? Like this, something like this. So let's say this is mountain, right? And this is one more, right? So 3 different elements we have, 1 2 and 3, okay. So now let's suppose let's suppose if I want to make this 1 as 0, right? If I make this 1 as 0, right? So if I make this 1 as 0, so in that case this will act as one boundary as well, right? This is going to act like a boundary as well, right? So here how I'm going to solve this problem then, how I'm going to solve this. Okay, so let's see like this. So first we have 3, right? So definitely if I want to remove 3, right, I need one operation, right? I need one operation. Okay, to remove 3 I need one operation. Okay, after that my next element is 1, right? So this is nothing but decreasing slope, decreasing slope, right? 1. So here see, for 3 I need one operation, for this one also I need one operation, right? I need one operation for this one as well to remove it. Okay, to remove it I need one operation. Clear? Okay, now here again increasing slope is there, increasing slope is there too, right? So increasing slope is there, right? So if we have increasing slope, right, definitely I'm going to need one more operation, right? Because smaller element, right, if I consider this array as a whole, right, complete subarray, so in the very first go I'm just removing the smaller elements only, right? Always, right? If you see here in one operation you can select a subarray, right, and set all the occurrences of minimum non-negative integer in that subarray to 0, right? Minimum only I'm considering, right? The next time here we have 2, next time we have 1, right? So now if I have 1 right here, so see this one was already there in the past, again one more 1, right? So if I can remove this both 1 in one operation, then for 2 I need one operation and for 3 I need operation, right? These one are same, smaller elements, right? These one are same, right? So for these two only one operation will be there, for this 2 there will be one operation, for this 3 there will be one operation, right? Clear? Clear? Okay, now in total we have 3 operations, right? 1 2 and 3, in total we have 3 operations as output. But here how do I know that this one and this one I can remove in one go, right? There may be 1 0 1, right? In this case we have to take 2 operations to remove, to make my complete subarray as 0, right? First for this subarray and then for this subarray. But how do I know this? Okay, so I can do one thing, I can do one thing, I can use something like this. Okay, so let's say first element is 3, right? Initially this, let's say one list, right? This is one list. Okay, so this list is empty initially, right? So if this list is empty, so I'm going to add very first element 3, right? And if I'm adding any element in the list, let's say I'm doing one operation for this one. Okay, hope is go to 1, right? Now after that when I move to this one, okay, when I move to the next one, so I'm moving to the next one, right? My list is not empty, right? And the topmost element, right, the last element that is there in list, right? Right now in list only one element is there, right? 3. So if you see the last element in the list, that is nothing but 3, right? That is nothing but 3. So 3 is greater than 1. 3 to 1 decrease in slope, right? Decrease in slope, right? So if there is a decrease in slope, right, if there is a decrease in slope, what you need to do here, remove this element, right? Remove this element. So if there is a decrease, so definitely this is a higher element and this is a smaller element, right? So definitely this smaller element is going to become 0 first, right? Okay, if you just consider this, then this is going to become 0 and then you have to consider this. But here, so understand it like this, now you have 3 and you have 1, right? If you take both in one go, this is going to become 0, right? But let's suppose this is one more case now. If you just take this as one subarray, right, then this is going to become 0. But still, if you see, among these two, one element is still there. Among these two, one element is still there, left out, right? So definitely for 3 I need one separate operation always, right? If there is a decrease in slope, definitely for 3 I'm going to need one operation, right? So this is the case, right? So here I'm just going to do what now. Here we already did 3 when for very first time when I have added 3 in the list, I have just increased the value operation to 1, right? Right. Next time when I see 1, right? So 1 is smaller than 3, then in that case decrease in stop in the slope. So I'm going to remove this 3 now, right? And I'm going to remove this, and now if you see, a list becomes empty again, right? And for 1 there will be a start of new operation, right? There will be a start of one more operation, so 1 plus 1, right? So I told you, right, 3 and 1. So here in this case we will always going to have two operations, right? Whether we remove 1 first and then 3, or 3 first then 1. Okay, so 1 plus 1, right? So now I'm going to add 1 here, right? So this is a decrease in slope, right? This is done. Now next time element is 2, right? Next time element is 2. Increase in slope, increase in slope, right? Here it's nothing but increase in slope, right? Now in this case, if you see, the old element is 1, and tell me 1 is greater than 2? No, right? So previous time when 3 was greater than 1, true, so we were removing the element. In this case I'm not going to remove the element. Okay, now there is an increase in slope. Okay, so that simply means if I have 1 here and I have 2 here, right? 1 and 2. Okay, so this is the case that I have right now. Okay, so definitely if I am adding a new element, right? First let's say I have added 2 here, right? I didn't remove this one, but let's say my list is not empty and the last element of my list 1 is smaller than 2, right? So for I'm adding new element, right? I'm adding a new element, right? 2. So for this one, first I need to increase my result, right? Definitely I have to increase my result, because previously it was 1 and now there is increase in slope, right? So if I'm removing this, then again a new layer is going to start. That simply means a new layer is starting from here. Okay, now here if you notice, I've added this and my overall operation become 3. Okay, now see here, listen carefully now. Now next element is 1, right? Next element is 1, right? Okay, 1 means decrease in scope. 1 means decrease in scope, right? Now last element in my list is, last element in my list is 2, right? And 2 is greater than 1, right? In this case I have to remove it, right? When this condition was true, last element greater than the new element that I'm adding, I'm going to remove it, right? Now next time if you see, my list is not empty and the new element that I am adding, right, new element that is I'm seeing here 1, it is equal to 1, right? In that case don't do any update in the list, don't do any update in the list. We are not updating anything, right? Because 1 and 1 both are same only, right? Both are same only, right? Why do I need to add it, right? This is just 1 is nothing but the layer of this one, right? Okay, so here what we did, we first see this layer right? We add one result. Okay, then we just see this layer, then we just see this layer, we added one more value in my result. Okay, plus one here. Then we see increase in slope, then we added one more result, then we see decrease in slope, then we have removed this old value, and then just see that both are same only, we don't do anything, right? We didn't do anything. This is what we did, right? So here if you notice one more thing, the list that I'm creating, in this list I'm not adding the same values, right? I'm not adding the same values, right? In this list if you notice, I'm not adding the decreasing values also. Decreasing values. In this list, I'm only adding the values when they are increasing in increasing order. Okay, when they are increasing order, I'm only adding the values, right? So this list is acting nothing but just like a monotonic stack. Monotonic stack. Okay, this is how this list is acting, right? So we will see a few more examples, right, so that you guys get better understanding. So let's see this example: 1 2 1 2 1 2. Okay, so here 1. Okay, this is 1, right? So simple thing, first element, add this to your list, add this to your list, and update your result as 1, right? Result plus plus, add to list. Next time element is 2, element is 2, right? So if the next element is uh, greater than this, right, then there is no impact, right? In the list is monotonic stack, we are going to increase it too, right? And now if you see, we have added this, right? We have added this because our last element is smaller than this, so we have added this to list and we operate my result as +1. Okay, now next time 1 is coming, so 1 is nothing but decrease in, right, decrease. So if this is the case, right, if the last element in my list, which is 2, is greater than this new element, right? So what we do need to do, then we need to remove this element. Okay, last element, right? Remove it. And now if you see, my list is still not empty, and the last element of my list, that is nothing but 1, tell me if it is smaller than 2. No, right? So there is no update, right? Because this 1 is acting like a one layer only, right? So there is nothing I did here. Okay, so this is done. Okay, now next time we have again 2, right? Increase in scope, this slope, right? Increase in slope, right? So now when there is an increase in slope, then in that case, what you need to do, what I told you, then you have to add the element in the list, right? And just update the result as 1. Okay, now again decrease in slope, right? You have 1. So when you have a decrease in slope, right, in that case, what you need to do, first you have to remove the last element, right? Decrease in the slope 2, and here we have 1. So let's remove this last element, right? And there is no update in the result. Okay, now again increase in slope, you have to add the element and then you have to update the result. So overall result is 4. That's it. That's it. Okay, so here see, initially this one is acting one layer, right? This one is acting as one layer, we update the result. Then there is an increase in slope, so we update this as my result. Now there is a decrease in slope, right? So we remove this, right? So it's like this, right? So we are moving below, so definitely this smaller element is going to become 0, right? And I gave you example, right? 1 2 1. So here if you see, smaller elements is this and this, so both are going to become 0, right? And then if you just pick this, then this is going to become 0, right? So how many operations you are doing in total? You are doing uh, one operation for this alone and this, total 2 operation. So this is the same thing na? Here now there is a decrease in slope, so you are going to take this as one operation, right? So total 1 and 2 operations as of now. Then increase in slope, so increase in slope, that means 2 here. So again for this one also we need one more operation, so this is new operation, right? And then again decrease in slope and all the elements are matching, so this is one operation, and then this is a new operation like this. Clear? 1 2 3 4, total 4 operations. That's it. Okay, so now let's see this some good example. Okay, so for this example the output is 9 if you see. Okay, so here we have 0, then we have 2, then we have 4, then we have 3, then we have 2, right? Let's make it a little bit more clear. Okay, 0 2, and then we have, let's say, 4 here, and then 3 here, then 2 here, 0 2 4 3 2, then 1 we have, let's say, 1 here, then we have 2 back, okay, 2 here, then we have 3 here, then we have again sudden drop to 0, then 5, let's say 5 here, okay, and then after that we have 1, let's say 1 is here, and then we have 7 here, okay. So see, now for this one, if you notice the number of operations, so first element is 0. 0 you can ignore now. There is no need to do anything for 0, right? 0 is already 0. Why I need to waste any number of operations here, right? So 0 is already 0. Okay, now next element is 2. So for 2, right, right now your list is empty, add 2 in it, and your result update to 1. Okay, this is done. So this is done. Okay, one operation. Then increase in slope, right? So 4, add it to this and give 1. Okay, done here. Now there is a decrease in slope. There is a decrease in slope. So decrease in slope, right? So definitely in that case, you have to remove the last element from this, right? You remove the last element. Now here 3. So 3, if you see last element in the list now 2 and 3. So 3 is bigger than this 2, right? This 2 is smaller than 3. So again, that simply means same, both elements are not same. So that simply means I need to do one more operation, and here I have to add 3, right, like this. Clear? So this is one more operation, right? Because before that there was no 2. 3 is very first time, right? Okay, so that's it. So we have here something like this: 2 4 and then 3. If we have 2 4 and then 2, then I can take this as one layer, na? I can take like this, but here we have this one is separate layer, this one is separate layer. Okay, that is what I meant to say here, right? Clear? So this is done. Now after that we have to decrease in slope. Decrease in slope, so whenever you see decrease in slope, so just do one thing, decrease in slope, right? So remove the last element. So 2, now here previous element is 2 only, so that's it, stop it here. Okay, now here if you see we have 2, right? Okay, we have 2 here. Now understand carefully, and the last element of result list is also 2, right? So in that case there will be no update, because this is going to act like a one layer, right? So you have 2 4 3 2, so you are going to pick this complete as 1 in one go, right? 0 4 3 0, right? And then next time you pick you take this, so you are going to make this as 0. Then next time you pick this, so like this now. So 4 3 1 layer, 4 4 1 layer, and for this complete layer. Okay, so that's what we have to do here. Okay, done. Done. Now next time we have 1. Okay, now 1 means decrease in the slope. 1 means decrease in the slope. Okay, so now 1 means decrease in the slope, so we have to remove this element also, right? Remove this. Okay, now list is empty, add this one here and one more. Okay, done, because a new layer is starting from here, right? We haven't seen this layer, and in the list always I am maintaining the elements in increasing order, right? The next time we have 2, we have 2. So now we have 2, right? So increase in slope, increase in slope. So I'm not going to make the adjustment of this like this, right? Why? Because 1 is smaller, this is going to become 0 first, right? Then this is going to act as a boundary, so this is a new element, right? So here I'm adding 2 and here I'm adding plus 1, so this is going to act as a one more. Okay, then we have 3, increase in slope, add it to list, and plus 1, because this is going to act as one more layer now, right? Because here something, right, smaller elements, they are going to act as a boundary, so this is not going to follow up like this. Okay, so this is a new boundary, right? Next time we have 0 0, you can skip now. There is a decrease, right? First there is a decrease, first there is a decrease, So if there is a decrease, so definitely 3 is greater than 0, remove. 2 is greater than 0, remove. 1 is greater than 0, remove. We have to remove it. But now if you see next element is 0, we don't need to do any operation result. So again I'm starting from here, right? Next element is 5, add to 5 and 1 operation, right? Then decrease in slope. So if there is decrease in slope, remove this element. Here add 1 and one more operation is going to start now. Okay, right? Next time element is 7, add it here, and there is one more operation for this, like like this. Okay, so here overall result 1 2 3 4 5 6 7 8 9 9. Okay, 9 is my output. That's it. Okay, so here if you see diagrammatically, 1 operation, 2 operation, 3 operation, 4 operation, 5 operation, 6 operation, 7 operation, 8 operation, 9 operation, right? So this is what you need to do, right? So now let's write the code for this. Very simple. Okay, so here what you need to do, first thing, create one array list of integer, and here list is equal to new array list, right? And you can say this is nothing but x like a monotonic stack, right? And initially result value is nothing but 0, right? So it is nothing but operation counter, right? And then you have to just iterate over all the elements in your nums array one by one using enhanced for loop. And here we have to maintain a increasing, right? I'm writing non-decreasing stack, right? Increasing stack only. So here first thing you have to make sure that if your list is not empty, right? If your list is not empty, and list dot get the last element, list dot size -1, right? You get the last element. So if this element is greater than num, right, the new element, right, so you have to remove this last element, right? So list dot remove, and here list dot size -1, right? So this is what you need to do, right? So in this way we are going to maintain a non-decreasing stack. And I told you that if your number is equal to 0, then in that case you have to simply continue, right? So skip zeros, right? And they reset the segments, right? They reset segments, right? So this is next thing. And now if this value, right, the new value, if this value introduces a new height, right, not previous height which is already there in list, a new height, right, that simply means new layer. Okay, new layer. Then in that case just here right now, if your list is empty, okay, if your list is empty, or list dot get list dot size -1, right? List dot get list dot size -1, last element of the layer, right? If this value is smaller than the new value, right, num, right, in that case you have to update the result, right? So like here 1 and after that 2, right? So we have to add the 2, right? Okay, so previous element is smaller than 2, right? So we have to add a 2 in our result, right? Result plus plus new layer, introduction of new layer, and then in the list I have to add this new element as well, list dot add num, right? So here what we are doing, we are push it into the monotonic stack, okay, the list which is acting like a monotonic stack. And here what we are doing, we need one more operation for this new layer, right? And in the end you have to just simply return result. That's it. So here, let's run the code and see if there are code issues. So see, all the test cases has been accepted, right? Now let's submit it. The time complexity for this problem is going to be of n, since we are just iterating over all the elements only one time, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.